Out here in the shop today, finally getting back on the old Heider project. The goal here was to just get the motor running. I didn't have the time or the room to rip this apart and do a full restoration. What I want to do is get this ready for the last show of the year. It's taken some time to get some parts collected. Had some other delays. Last year was really busy. But I would say I've got 99% of the pieces done, collected, finished for what we need. Today's just going to be a review of what we have. I had to watch one of my old videos to see where I left off. But we have the base all babbited up, repaired. We have some brand new pistons that were custom made for this application off the dimensions. Brass valves are cut, rods have bearings in them. Just kind of going to go over all this, take a look and see what we're getting into. Let's get started. Let's start with one of the more interesting pieces. The engine base is cast aluminum. As a reminder, this was built on the last day of 1917. So I wouldn't imagine they had aluminum casting really figured out. It's kind of porous. And if you remember, it was a little bit dirty. This ended up having to get cooked to get all the grease out. And when we pulled off the main cap on the front, there was a crack that was into the case, which I thought might have been a showstopper right there, because if you don't have this piece, you ain't building an engine. I found a great welder over in Wisconsin, did a good job, got that patched up, had to get a line board drilled and tapped for the bearings. Take a look across the top. These are where those headless blocks go. They bolt on the top of this. All the holes you see here are for the roller lifters that poke up. Directly underneath, it's where the camshaft rides. Comes out the back with a bevel gear, which drives an oil pump that goes externally driven onto the bottom of the oil pan, or out the back of that, which I'll show you in a minute. I'm fortunate enough too to have all the casting numbers match, or the serial number, 25901. This is the correct tag, 25901, and the tag on the tractor is 25901, and I'll show you the hand-stamped serial number on every connecting rod, 25901. So let's flip this thing over and take a look at the Babbitt. Bottom view. Main caps are all aluminum, threaded into that old aluminum. I have no torque specs for this, so it's going to be nerve-wracking torquing that down. This was extremely labor-intensive for the Babbitt guy, because this did not have shells in it, and every one of these is a different width. So everything had to be custom fixtured, poured. All the oil grooves are hand cut. The side thrust surfaces are all fitted to get the crank to ride where it needs to. Here's some more of that repair. You can see the difference where it was machined. And seeing this on the line bore machine, you could tell that the weld was actually better material than the original casting. These are shim packs. So as your Babbitt wears, you can tighten up your bearings. With a little bit of use this will get, I doubt I'll ever have to address that in my lifetime. But this will be kind of nerve-wracking to put together, just because of the information, the homemade parts. It's gonna be a project. We'll move on to the next thing. Once the blocks were bored, I believe they were 60 over was what it took to get them square again. We decided not to line them. The pistons in this thing were junk. You can see right there on the ring lands, there's like a blacksmith repair here. It's not exactly round. I don't know if that was cast, scored. So to sleeve them and try to get these pistons to work, find big fat rings. The piston ring land groove was like 50,000. I mean, they're slapped out, bushings and all that. So it's just easier to have brand new ones made off the dimensions. Now, I'm not a mechanical engineer, or even a mechanic for that matter. And so it's one thing to build a wet sleeve engine, very easy, throw a kit together. So this, I needed to get some advice from the piston builders and the machinists and stuff, and trying to figure out what piston wall clearance you need, all that kind of stuff, you know, because we're using a different material now. It'll expand different under temperature and all that. But anyway, Ross ended up making these, brand new aluminum forged. They're set to a common ring now. The bore is 4 1/4, which, or was factory, which I believe is the same as like a big block shove. So now at least I'll have common rings. I can just order, well, I should never need to do rings, but get the picture. Use common stuff, it's cheaper, it's easier. So that's what we have for that. Kind of got the pieces laid out. Those how the valves ended up coming out. I can't remember if these were showed before. These were bought originally as blanks. They had to be cut to length and they had to have the grooves cut in them for the keepers. And the valve guides were reamed out to accommodate those valves. And if we need to in the future, we could put guides in them. There's enough meat in there. The other thing that's kind of nerve-wracking about this is these are headless. So you don't have any access from the top. And to put this motor together, one of the things I got to be aware of too is once I put the rings on here, if I don't do this just right and that piston falls too deep into the bore, I could spread a ring in the combustion chamber and then you're stuck. You basically have to break the ring to get it back apart. I think I covered these on that last video. I know it's been a year and a half. These are decked true. They're ready to go. They just need a final clean. For the assembly, moving on, here are the rods. They're all numbered. Oddly enough, they have all the same part number on them. But if you look where the wrist pin goes, you can see how this is offset. This one's not. This one is. And the reason for that is because there's two separate blocks. There's a bigger gap where you put them on the base, and so they need to be offset slightly to get the pistons in the right position. These are all fitted to the crank. The crank was trued up, again, poured by hand, hand-cut oiling grooves in them. Like I was mentioning before, 25901. Every one of these has a correct stamp on it. So they were all indeed built with this motor serial number. These were the pinch style. It's kind of like, I believe an Alice Challenger is that way, where the wrist pin doesn't float, it's fixed. And believe it or not, getting the right wrist pins was extremely difficult because no manufacturer lists them dimensionally because they want you to buy their exact part. So with several phone calls back to H&J, and I think he's in North Dakota. Great guy, gave me a little bit of time to give me some dimensions of what I was looking for. I ended up buying these from Eggy out in California, and I think they're only like 16 bucks. And these actually have a thicker wall than the factory ones, but they come blank. So the challenge becomes trying to get them to match the original ones, because since they're fixed, they have oiling holes in them that drip in the top of the connecting rod, then runs around inside of it and then drips through those holes to lubricate the piston. And one thing I got to do yet is grind a little material away there. The factory ones had either like a slice in them so the oil could slip around in there, or in this case I just ground it flat. These pinch bolt, I don't know what you call it, a retaining groove. You can see it's slightly offset, which matches the shouldering on the piston. So you got to pay attention to everything when you're making this stuff because it takes so long to get these parts. And this material ended up actually being thicker than this stuff. We did a practice cut in the machine. Let's see, one of these are actually cut through the wall to just make sure we could replicate it. And this material is so insanely hard. Broke end mills, broke carbide drill bits. And you want to hear the funny part? When we cut all these grooves in here, I did it in a Bridgeport with a Harbor Freight Chief carbide cutter, and it lasted for all 4 of them. That's something else. So a little bit of work to do on those. Here's the big parts pile. Now I'm starting to try to remember. I think I got an idea of how most of it goes, but some of it's going to be tough to remember exactly. This was the crank pulley. This was cracked on 3 of the 4 pieces of webbing in there. So again, same guy that repaired the base did a fantastic job. Fixtured this up so it was perfectly round, V'd it out, welded it up, peened it. Again, it's a part you can't replace. There's our roller lifters. I did a whole thing when I put this governor assembly back together. This has all been repinned and everything. Oil pump, very basic, just a couple of gears. This is the piece that comes down the back. That's the oil pump drive, goes on the back of the cam. That's the screen and the spring. That's basically your oil filter and that motor that goes in the back of that pan. The pan has 4 dipper trays. I'll show you on the bottom of the connecting rod. These are the scoops. The oil pump's only purpose is to fill these trays full of oil continuously. And then the connecting rods come down and splash it around. With a lot of struggle, I was able to get this tray out and clean this. That's where the oil pump mounts. There's 2 drain plugs. The one here is recessed, collects all the junk, and that spring and screen go here and draws all the oil across, and the sediment drops down. This pan is solid cast. It's extremely heavy, and I believe that's what gives us its form. Going back to this base, we did have one other crack in here. You can see the material in there, I don't know. And opted not to repair this because of how brittle and thin the material is here. You just might end up chasing it around, and who knows, this could have been cracked for 100 years. So we're gonna rely on this pan to give it its structure, basically, because this, will make it rigid. A couple other things. Over all the years, you always hear about combustion gases, condensation, short trips on engines, all that kind of stuff, and what damage it can do. I've taken a lot of stuff apart. I've never really seen much evidence of it, and I know this is an extreme case, but if you look at this drain plug, this is the one on the bottom under the oil filter. It's actually eaten away, and when I was cleaning this, I kept scraping all the sludge out, and it just smelled like old gas. That's a plug that was in the bottom of the oil pan. You can see it's literally just dissolved. There's a retainer fastener for one of the dripper trays. And I know this is an extreme case, but it's kind of interesting. It's real. Definitely seen some damage from it. It smelled like gas. I don't know if they burned kerosene, the stuff leaked down. But this is probably getting fairly long. Here's that replacement disc for the friction drive. And that was Paper Pulleys in Columbia, Tennessee. I called them up. They had dimensions still on file. I just verified it. And I started ripping into this one and lined it up, and it's pretty much a perfect match. I don't think I'll really have to modify anything. This is the original, or not original, I'm sure it's replaced at some point. You can see this is all pretty rotten. So I'm gonna ease into this project and kind of start doing the easy stuff first. That'd be a good warm up for me. And I'll leave you with one final note. When I talk about there's no paperwork or no specs, Mr. Obsolete Vintage Homesteading on YouTube sent me this manual. I think I did a shout out video for him. Definitely appreciate it. And this has some stuff in it. Gives me valve clearance, gives me some ideas of how to put this together or how it was intended to, but definitely lacks detail. So for example, kinds of oil to use. For pleasure cars, thin. For trucks, thicker. For tractors, gasoline, heavy. For tractors, kerosene, heaviest. So doesn't give you a weight, doesn't give you a quantity, anything like that. And it has such other helpful stuff as like, tighten fastener down, tight but not too tight, things like that. But it definitely will provide some information. Like I said, gives me the valve clearances and stuff, no torque specs, and gives me some idea of how I should assemble this. And basically for service, they basically say, with the blocks on and everything, you pull it out and you just lay it on its side. That's for adjusting the shims, but that's probably the best way to put the pistons in, so it just makes me nervous with that old aluminum and stressing it and stuff. But this one's long enough. I'll bring you back for some of the assembly, kind of in a hurry, and I'll be figuring it out as I go, so I'll probably just do highlights and maybe do one part of each assembly. Till next time.